Okay, so how is everyone today?
Halfway through, and I have not crumbled into little pieces.
All right. Okay, so a few announcements and reminders, really, about the exam. So there's an exam, in case that was not clear. There's an exam in 5 days in lecture on Wednesday. The exam is going to consist of 2 parts. There's going to be 3 cumulative questions. 3 cumulative questions covering Wex's up to and including uh, 192, which is what we're doing today. So up to and including that one. So more or less, as a reminder, what these numbers mean is that this is the lecture number and that's the question number. So Friday, 7 days ago, we had lecture 19. So I suppose that this is lecture 22. Okay, so what I'm saying is that the exam is essentially over the first 19 lectures. Fine. So that's each one of these questions that the Wexes were over. That's kind of like each one is sort of a pointed topic. Each one is asking a very specific thing. These cumulative questions, what I will do on those is select 2 different topics and then sort of mash them together and make an exercise over both of those topics. And the purpose of this is so that I can see if you're able to synthesize information, right? You're able to do something from task A and also something from task B and put them together, right? Because what I need to know is if you can sort of do them at the same time and not get lost. After that, you can redo up to 10 of the out of 10 Wexes. And this is up to and including the 19X's. So to be clear, what that means, and for those of you who haven't entirely caught on to it, corresponding to, for example, lecture 7, we had a Wex called 072. Well, let's start where it begins. We had a Wex called 070. We had another Wex called 071, and we had another Wex named 072. And all of these correspond to lecture 07. And then for each such set, I select one of them to be graded out of 10, and the other 2 are graded on completion. It is usually the case that the last one, which is the quiz, is graded out of 10, but not always. Sometimes the ones that you do at home are graded out of 10. But at any rate, the list of which are graded out of 10 is on the web page. So what I'm saying is that for each lecture, something was graded out of 10, and you can redo up to 10 of those out of 10 exercises. So the exam is going to look like this. You know, the first page is going to be well, this is where you put your net ID and your other information. Say, here I am, it's me. Then there'll be 3 pages corresponding to the 3 cumulative exercises. Then there'll be a little page that says, now after this are redo opportunities. So here will be a page. Maybe this corresponds to, say, WEX 010. I have no idea. And then this one corresponds to, say, 022, all the way to the last page. So you must do all of this. And then as for these, you do up to 10 of these. I think there's 20 possibilities. Okay, so then you should bring a list of WEXs you want to redo. Now, to be clear about that, I don't mean bring copies of your homework. I don't mean make a cheat sheet. I don't mean anything like that. I mean that you can have a little bitty sheet of paper that lists them out so that you know which ones you want to do. It might be a good idea for you to do something like, well, on 010, I made a 7, and on 022, I made a 9, all the way down to whatever, just to list them out. There can be no math information here. This is not a cheat sheet. So, you know, maybe like on 191, supposing that one is the one that's graded out of 10 today, you make, you know, maybe you forgot to bring it, and you make a 0. Because I think it would be, it's senseless for me to ask you to just memorize what you made on WEX 11.2. Who has any idea? I have no idea what you made on it. Okay. So you can select up to 10, and the reason for up to 10, if the world were perfect, I'd say I'll do all of them. But I only have a finite amount of labor that I'm allowed to assign to my subordinates, and I won't find out until after the fact whether or not you attempted more than 10. So if you attempt more than 10, I will have gone over my labor allotment, and I'll penalize you for attempting more than 10. Now, it might happen that you wanted to redo one of them, and you started to redo it, and you realized, no, I don't want that to be one of my 10. Well, there'll be a way to mark it and say, no, this isn't, not this one. Don't regrade this one. Also, remember the policy is that if you attempt a redo, then that will be your grade. So what I mean by that is that perhaps it's the case that on WEX 032, when we took it in class, you ended up making a 2 out of 10. And you were not happy about that result. And then on the exam, on the midterm, you do redo 032, and you make a 9. Well, then your grade's a 9. But it cuts both ways, which is to say that if maybe like you're a perfectionist or something, and on WEX 072 you made a 9, and you think, oh, I just can't stand that. Can't stand that at all. So on redo 072, maybe you make an 8. Oh, then your grade's an 8. Okay? If you didn't do one of the out of 10 ones, like maybe maybe it's the case that 191 is going to be graded out of 10 and you just didn't do it or forgot to bring it or what have you, then you make a 0 on it. And you can redo it. That can be one of your redos on the exam, and you can have that grade for it. Any question about anything? Yes?
Like, is the entire exam also going to be graded out of like a 1 through 10 scale?
These 3 are out of 10,
Okay.
and then any of these that you do are also out of 10.
So, like, what I'm wondering is that, are we ever going to, like, so we're saying that, like, 8 corresponds to 80 and 9 corresponds to 90. Is there, like, any way to get in between those numbers, or just...
Well, you have a WEX component of your grade. So let's say, for the sake of argument, that there's been 20 out of 10 WEXs graded so far. That means that there's 200 points possible corresponding to that. And let's say further, for the sake of argument, that 40 other WEXs have been graded on completion. Well, that's a possible 40 points. So altogether, if those numbers were correct, then there'd be 240 possible WEX points. Your WEX grade is the percentage. So like maybe on the out of 10, you got 180 out of 200 possible points, and on the completion ones, you got 38 out of 40 possible points. 190 plus 38 is what it is. Divide by 240, make a percentage. Yeah?
There were a couple of days where the quizzes were left in the printers.
Yeah.
What, on those days, what was counted out of 10? Was it one of the homework?
Uh-huh.
Okay, and so I think maybe those days haven't appeared yet. Maybe, because I don't remember seeing anything other than that, something ending in it too.
As I understand it, they're all up there.
Okay.
I think you mean in the PDF, in the keys, or do you mean in the scans?
Yeah, in the scan.
They're there.
Okay, okay. And then I was under the impression that it was just the out of 10 homeworks that have the opportunity to be redone, but that's not true. You're saying they're all, even the zero, even the completion ones where there's only...
No, not the completion ones. The completion ones don't have the opportunity for redo.
Okay, so you're just saying, like in that instance where it was 191, you're saying that was a one that was counted out of 10.
Right.
Okay.
So like today we're going to do 190, 191, and 192.
If it were the case that that was a 10-pointer, then it would be available.
Right.
Got it.
And then PDFs and videos for all of the out of 10 will be keys will be posted. At the present time, I think like up to like 15 or 16, I think is posted. Yes.
Every single one that we've done, like homework-wise and quiz-wise and the quiz, they've all been posted online, right?
You mean scans? Do you mean graded and
Yeah, the graded version.
everything up to and including 15, and then 16, 17, 18, and 19 will be posted today. Yeah. So I'm grading 18 and 19 myself, right? So that we can have a real quick turnaround on those. Yes?
If we were here for a class period and don't have scans showing us which ones are out of 10,
Mm-hmm.
is that on the calendar?
Yes. If you go to the calendar page, it shows you which ones are out of 10. Yeah.
I'm sorry, I have one more question.
Yeah.
If I'm preparing for this midterm,
Mm-hmm.
my philosophy is to go through and do every WEX again.
Okay.
Would that be sufficient preparation, or is there a chance that I need to? It's something that might appear on a WEX was only in lecture notes and not on the WEX activities.
Well, okay. I mean, by and large, the questions that I'm interested in, I asked on the WEXs. So if you redo every single WEX and you're comfortable with everything, I think you'll be just fine. Yes?
So the exam is basically like putting in Wexes, and
Yeah.
you can just choose between the other ones,
You can do 0 of the redos if you like. That'd be really cool, wouldn't it? Just, no, I'm not even doing them. Out. Okay, let's get to work. So last time we were talking about absolute value equations. Good. So to remind you of those kinds of things, the shape of absolute value, when you plot it, is a v. So it's a v. 2, when you solve particular equations involving absolute value, various kinds of scenarios can occur which more or less are reflective of the shape of absolute value. So we could ask, well, what is the solution to 2w minus 3 in absolute value is equal to 8? Well, the way you go about doing this is you say, well, I'll cover up that and then ask myself, what kind of input could I provide to the absolute value so that the output would be 8? 8 or negative 8. As a result, this equation splits into two separate equations because there's two possibilities. 2w minus 3 is equal to negative 8, or 2w minus 3 is 8. So that is to say, the input to the absolute value could be negative 8, or the input to the absolute value could be 8. Then these two equations are straightforward now. So I'll just race through them. 2w is negative 5, or 2w is 11. So w is negative 2.5, or w is 5.5. Okay. A visually similar question, but with a sort of little bit strikingly different answer, is what if we look at absolute value of 2w minus 3 equal negative 8? So please solve that. Now that equation visually looks very similar to the one to its left. But what? Yeah, so what's the response to being asked to solve this? That there's no solution. Because again, you're asking, what kind of input could I provide to the absolute value so that the output would be negative 8? And the answer is, there isn't an input that would do that. That's not the kind of thing that absolute value does. So the answer now is that there is no solution because the output of absolute value is never negative. And again, to get credit on such an exercise, both of those components must be there. You have to say that there's no solution. But that's not enough. You have to say there's no solution because something like this. The output of the absolute value is never negative. Okay. 3. What else? We have something like the following. The square root of negative 16. How do you respond to this? If I say evaluate this. This is undefined. What if I modify it just slightly and I say, in the complex numbers, the square root of negative 16. Now what's the answer? 4i. You can think of it, I want you to get to the place to where you can just respond 4i. But to help you understand why it should be the case, you can, as an intermediate step, you can say, well, could the 16 itself come out of the square root? If 16 came out, what would it come out as? 4. Okay, so 16 could come out as 4. What does negative 1 come out as? It comes out as I. Okay, so they each come out. 16 comes out as 4. negative comes out as I, so 4I. Okay, and I'd like to draw a little diagram to kind of help you understand what's happening. Is that in the reals, if this is the origin there, and I ask, what squares to 16? 4 and negative 4, right? So 4 and negative 4. So these will square to 16. And then among the reals, there isn't anything that would square to negative 16. Okay, but in the complex. So when you draw the reals, you draw them as a line. When you draw complex, how do you represent it? As a plane, right? So in the complex, again, we can have 4 here and negative 4. What do these square to?
16.
These square to 16. So square to, and just to kind of emphasize it, I'm going to write positive 16. So that squares to positive 16. That squares to positive 16. Now, here, if that's 4 right there on the real axis, then what's that? 4I. Right? This one is 4I. And what's this one? Negative 4I. So we have 4 and negative 4, 4I and negative 4I. Now what does 4I square to? Negative 16. And what is negative 4I square to? Also negative 16. So what I'm telling you is that with the complex numbers, you can pick your favorite real, say 16, and you could ask, what would square to 16? Negative 4 and 4. But you can also pick the negative of your favorite number, negative 16, and ask, what numbers would square to negative 16? Negative 4I and 4I. So it's exactly these except rotated 90 degrees.
Can you tell me briefly again why negative 4I squares to negative 16?
Yes. So, for example, I know you said negative 4I, but first I'm going to look at 4I. If we square this, then this square distributes, or even we could write it like so, 4I, 4I, if you like. Then we could commute the 4's to the front and the i's to the back. So this would be 4 squared I squared. Well, what's 4 squared? And what's I squared? Negative 1. So this would be 16 multiplied by negative 1, which is, of course, negative 16. What I want you to observe is that a very similar thing occurs when you square negative 4i. You get negative 4i multiplied by negative 4i. We can commute the negative 4's to the front now. so that we'd have negative 4 squared multiplied by I squared. But what's negative 4 squared? 16. So again, this is 16 times negative 1, so negative 16.
And what keeps the negative from distributing to the I is that there's a multiplication between it, like at the very beginning of that problem where you have negative 4 times I. Like that's what I was thinking in the beginning, which is why I was confused. Like there's a negative in front of the 4.
Well, okay, now I understand. So negative 4 I, that's actually, you could think of it like, well, you could imagine it like the following. It is negative 1 multiplied by 4 multiplied by I. Now, you can move the negative 1 into any position that you want, because multiplication commutes. So you could view it like this. You could view it like this. You could view it like this. But in the end, there's just one negative 1. It sounded to me like what you were asking is this, so question mark, is this equal to this?
That's exactly what it was. Right.
And the answer is no. That can't be right. That can't be right because this first one would be negative 1 times 4, and the second one would be negative 1 times I. And then the question is, well, do we have the correct amount of negative 1s? The answer is no. Other questions? Yes?
Can we stop at I squared, or can it go, can it be like a I to the fourth root?
So that we covered that last lecture. So I've got to keep going, but I will be happy to see you after lecture on that particular topic. So
Oh yeah, I have it, sorry.
here's another example. So how about please solve 2w minus 7 squared is equal to 100. Okay, so now this is the first kind of in this style. So since this is the first time I've asked a question in this style, I'll show you how to answer it. So there's two ways to respond. And I just need you to do one or the other. I'm not saying that you have to respond in both ways. So one way is to say, all right, I'll take that 2w minus 7 squared equal to 100. And the issue is that we need to get the w isolated. But at the present time, it's inside of the square, right? It's in there. We need to get it out. So that means that we need the square to move to the other side of the equation. How do you get the square to move to the other side? What, sorry? Square root. Okay, but well, you have to do square root of both sides, right? So square root of 2w minus 7 squared is square root of 100. So we'll do square root of both sides. Now, square root of 100 is easy enough, so I won't even ask. It's 10. What is the square root? What do we need to replace the left-hand side with?
The absolute value of 2w minus 7?
The absolute value of 2w minus 7. So the most common error, incorrect response is this, omitting the absolute value. But you need absolute value. The reason is because, please recall, that the square root of x squared is the absolute value of x. Now, what I want you to see is that, oh, this is just like the ones we did last class, isn't it? So what could you provide as input to the absolute value so that 10 would come out? Negative 10 or 10. So I'll just rush through that, because now that's boring, because we did that last time. So 2w minus 7 might be negative 10, or 2w minus 7 might be 10. And now here's two equations you could have solved probably even before college algebra. So 2w could be negative 3, or 2w could be 17. So w might be negative 1.5, or w might be 8.5. All right. Another equally valid way to respond is, okay, I'll take that equation. 2w minus 7 squared is equal to 100. Now, instead of using radicals, using square roots, we can do the exact same kind of trick here and just say, well, I'm squaring something. Squaring something, and after I square it, I get 100. What would square to 100?
10.
Or negative 10. So we can split it right here and just say, well, there's just two possibilities. Is that 2w minus 7 could be negative 10, or 2w minus 7 could be 10, which is, of course, exactly where we were right here. So now you just copy-paste the exact same kind of thing. And this is how I'm going to do this style from now on. Well, because it's shorter.
Can I ask a quick question about fractions? When we get something like 3 over 2 as an answer on the OHWs, would it accept either answer, or do we have to leave it as the fraction of 3 over 2?
On the online homework, it'll depend on the way the question is stated. I think it should work either way on the OHW. As for the written homework, I don't care. All right. So how about this one? Please solve. So different exercise altogether. I mean. Please solve 5y minus 3 squared is equal to 7. So this one always gives pause. Makes students take a pause and say, I'm not comfortable with this. Right?
You still have to take the square root of both sides, right?
You can do it that way. It's fine. But so what I want to point out is that when I did this on this previous exercise and I said, oh, I need something to square to 100, most of y'all said 10. And I said, and then you said, oh, yeah, negative 10. Right? And it was pretty straightforward. But now, if I do the same trick here, a lot of y'all have a little bit of pause and say, wow, I don't think there is anything that squares to 7. Well, of course there is. There's a name for it. What's the name of the thing that squares to 7? Square root of 7. Right? That's its name. Okay, so what squares to 7? Negative square root of 7 will do it, and for that matter, so will square root of 7. Okay.
That is definable, negative square root of 7. I was thinking that there's only one answer because you can't take the square root of negative 7.
So am I taking the square root of negative 7?
No, but I wouldn't know to do that. Like, I would definitely put that 7, put the square root, I would put it the negative
I see.
7 as the input.
So to be clear, negative square root of 7, this is real. The square root of negative 7 is not. It's the square root of 7. If you're dealing in the complex numbers, it's square root of 7i. is not real. Okay, so for this equation, there's two possibilities. So this one splits into two pieces. What's one of the possibilities? Right, that 5y minus 3 is one of the square roots of 7, the negative one, or 5y minus 3 is square root 7. Two possibilities. And now you just solve it in the normal way. Well, it could be that 5y is 3 minus the square root of 7. Or it could be that 5y is 3 plus the square root of 7. Then what? Divide by 5. So y is 3 minus the square root of 7 over 5, or y is 3 plus the square root of 7 over 5. Now, you might not particularly like that, 3 minus the square root of 7 over 5, but that's a perfectly legitimate number. It's not like an integer or something cool like an integer, but it's still a number. And just as a reminder, because students usually ask or even long for at the following moment, I'll remind you that use of the symbol plus or minus is not allowed in Math 13-14. Good. Any question about this one? Yes?
The plus or, like, doing the plus or minus,
Mm-hmm.
wouldn't that be a conflict of, like, if you put that in either one of those, either the 3 minus square root of 7 over 5 or the 3 plus?
Well, I'll tell you what students want to do. What students want to do is they want to write, instead of writing this copy and that copy, what students want to do is they want to make that one a plus or minus, that one a plus or minus, that one a plus or minus, because then, as I suppose, that means that, oh, I don't have to write as much. Well, I'm not having it. As far as I'm concerned, if there's a plus or minus on your page, it is by definition wrong. The reason is because I've witnessed too many students misunderstand what plus or minus means. Even graduate students. I pretty much have to, that comes up at least once a year where some graduate student is confused about the meaning of plus or minus. But when graduate students get confused, that's when there's multiple pluses or minuses on the same exercise. So there's multiple pluses or minuses and they can't figure out what it means. So no, it's just not allowed. Fine, how about this one? 2z minus 9 squared is equal to, I don't know, negative 36. Please solve. You got to remember the standing order in college algebra.
Take the square root of both sides.
Okay, but what would occur if you did that?
The right side would become on the bottom.
Okay.
Unless you put the negative on the outside of the square root sign.
Ah, but you can't do this.
Unless it's under complex
No,
number.
no, 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 no. No, no, no. No, no, no. Look. So we've got a thing. And inside of here, we put 2z minus 9 squared equal, and then we've got another thing, negative 36. And what what is being offered is that we could put square root of all of the left-hand side equals square root of all of the right-hand side. The negative cannot come out to play. The negative can't get out. It's stuck inside. So what's the correct response to this exercise? That there's no solution. In particular, there is no real solution. No real solution because, I mean, have a look. If we obscure what's being squared, in the first place, how do I know for sure that we're dealing in the reals? Why is this exercise an exercise in the reals? Because Simon didn't say, right? The only time that exercises are in the complex numbers is if the instructions explicitly state we're in the complex numbers. So the question is, what real could I square so that I'd get negative 36? There isn't a real. So there's no real solution. Because no real squares to negative 36. And that's the end of it. Suppose I do the next exercise and say, please solve. Solve 2z minus 9 squared equal negative 36. So right now it's an exact copy of the previous exercise. So the answer would be an exact copy of the previous answer. But now I modify to say solve in C. And this makes all the difference. Because now we have a complex variable. And the question becomes, oh, I'm squaring a complex variable. And the result is negative 36. What complex number would square to be negative 36? 6i and negative 6i. Okay, so then now the question is what squares? So what complex numbers square to negative 36? And the answer is, well, negative 6i and 6i. Those are the ones that do it. As a result, this equation splits into two possibilities. What's one of the possibilities? Is negative 6i. The other possibility, 2z minus 9, is 6i. And then now, I know there's an I there, and that's a little bit disturbing, but it's just a thing. Right? Now, symbolically, the manipulations are exactly as before, so I'll rush through that, and then we'll have the quiz. So that'd be 9 minus 6i, or 2z is 9 plus 6i. So z is 9 minus 6i over 2, or z is 9 plus 6i over 2. Finally, the last thing I want to point out is that in the last two exercises, if you have a look at what you've written, if what you wrote looks like this, then you need to stop. Okay? That's not how you write 2's and z's. You can't write them the same way. This is a math class. My goodness. Okay? The last thing you want to do is confuse the grader. And that's the worst thing. Okay, good. Let's have a quiz.